Hello, students. Today we're going to discuss something about bioplastics, which is a part of bioprocess technology course. In future, we have a topic bioplastics, which is comes under industrial bioprocess and its products. So we all know about plastics. They are a chemically synthesized product, which is widely used for so many purposes. But still, we know that it has so many negative impacts, mainly their degradable situation, which is not being easily degraded, so it will be a environmental pollution. So, what would be the alternative to the synthetic plastics? Here we have bioplastics. So, when you have the term bioplastics, it's not just a single group or a single material. Bioplastics are a large family of different materials. So, as I said, they were not a single material. Instead, they comprise the whole family of materials with different properties and applications. The plastic material also can be defined as a bioplastic if it is either bio-based or biodegradable or features of the properties. So when we have bioplastics or when we name something as a bioplastics, not only mean that the plastics are derived from the biological source. Even a normal plastic material can be defined as a bioplastic if either they would be isolated from bio-based origin or a chemical made or chemically synthesized plastics, but we have an ability to degradable under the condition of biological agents, especially a microbes which is available in the soil. Or it can be combining both properties. Either it's individual bio-based or biodegradable, or it's both bio-based and biodegradable. So what is bio-based? As we are well aware that the material will be produced from the biomass, plants, microbes, whatever it is. And biodegradable, the material is supposed to go for a biodegradation process, which is a biochemical process where the microorganism which is available in a certain environment convert the materials into water, carbon dioxide, and biomass. The process of biodegradation depends on the surrounding environmental conditions, especially temperature, normal humidity, pH, sun, etc. In compostability describes the property of being biodegradable under industrial or composting conditions. So, as we know that there are different types of plastics. According to the source where they have isolated, they can be named as renewable resources or non-renewable resources. Renewable resources, mostly they will be from synthesized from the renewable resources. Non-renewable materials, they will be extract from the petroleum-based products. So this figure shows the types of bioplastics. Um, so we have made a figure which is classifying whether they are bio-based or biodegradable and bio-based, as well as the situation which is non-biodegradable and biodegradable, bio-based or fossil-based. So if you see the bioplastics such as polylactic acid, polyhydroxy alternate, starch blends, they will be both biodegradable and bio-based. And bioplastics such as PPAT and TCL, they are biodegradable, but they were dependent on fossil-based. Okay. And bioplastics such as bio-based polyethylene, PET bottle, PTT, PEF are degradable, but they were not actually biodegradable. Okay. And the composition, as we say that the bioplastics might be a polylactic acids, PLA, or polyhydroxymalonic acids, various form of polyhydroxybutyrate, covalent, etc. So when we hear the bioplastics, that will go for a degradation process that is mentioned as a carbon cycle of bioplastics. So we have a plant which is obtains energy from the sun, which is a photosynthesis. Then carbohydrates, which is isolated from the plants, will go for fermentation that will produce a polyhydroxyalginate polymer. From that, we can produce plastics that we again go for recycling and the conversion of new product, as well as it will go biodegradation and produce carbon dioxide. When you have the biodegradable plastics or bio-based plastics, there are some plus and minus. If you see the pros, especially when you compare the bioplastics with the conventional plastics, they were the biodegradable or partially biodegradable. based on natural feedstock or partially based on natural feedstock. They have interesting properties like they will be from the renewable sources and cost image among consumers. It's equal. If you see the cons, yeah, quite obvious they were costly, and we have to use of genetically modified organisms for the improved production of plastics, and it can be easily go for brittleness and thermally can be degraded, so it cannot be used for long time usage, etc. We see the sustainability of which is improved based on the bioplastics related to petrol-based bioplastics. We got different, as I said, the comparison made with different bioplastics and the sustainable environment. We can go through it. If you see the environmental impact of bioplastic, it's from a renewable feedstock. It will demand the new biomass which can be used instead of the fossil fuels, chemical inputs, and water, etc. And manufacturing and processing, it's energy intensive process and may require potentially toxic petroleum solvents as well. We're not sure about it. End of life fate, it's compostable plastics, may be contaminated the recycling plastic streams unless they are properly separated and managed, otherwise it would be managed. So these are the different families of biodegradable polymers and their raw materials. So you can see biomass products, it can be classified into polysaccharides or protein lipids. Polymers which is isolated from microorganism can be named as different forms like major one is polyhydroxy alkanates, PHA, that we going to discuss in detail. And from genetically modified on polylactics. And when we use some combinations of petroleum products, we have polycaprolactones, polyacrylamates, etc. So, the next slide, we'll see synthesis of PHA and PHP. Whatever we have seen is general information about bioplastics. But according to our syllabus, what we have is a PHA. So, in our next session, we're going to see what is PHA and how they will be synthesized from the microorganisms.